So um, today is the second part for our DVT series. Um, our series is divided into three parts. The first one is about like a general introduction to the distributed validator technology, and how it works, everything we need to know around that. The second one is which is what we are going to be doing today, is where we are going to even see, a vanilla validator setup, right? And that's what we are going to be doing today. We are going to be going through everything that we need to know in setting up a validator node. And we are also going to be doing that as a demo, and we are going to be, doing that together. And then the last one is where we now set up a distributed validator ourselves, right? The reason why we are doing this is to sort of like create like a progression of learning where you learn about a new technology, you play or experience the problem that technology is solving. Like you experience the problem itself, and then so that when we are now exploring the new technology, you're able to like connect the dots, and the solution this technology is providing makes sense to you and is not abstract. Outside of the demo, we're also going to be explaining a couple of concepts that not a lot of people have actually taken their time to explain, or even taking their time to find out. So yes, getting started. So for today, we are just going to do not so much recap, since we don't have so many people. Although ideally, I would have loved if someone in the audience could just do like a recap, but since we don't have so many people joining yet, I don't know if anybody will be willing. But what I would love is for someone to do like a recap of what we learned last week, and then yes. So, and then we can now move on to that, to what we have for today. So we have recap, and then we have key concepts. Now, for this key concept, right, the reason why I took my time to want to explain it is because a lot of people run validator nodes and they have no idea what some things are doing. By the time your nodes is up and you are seeing your telemetry data, you are seeing your observability, a lot of people see stuff, they see committee, they see epochs, they actually don't understand what it means, right? And one of the things, or one of the leverage that we are going to have over others, is that we're actually going to understand what it means. And the reason why this is important is that when we understand what this means, it helps us optimize the performance of our validator better, right? And that's the main reason why we are doing this. And then, at the end of the day, when we are running our own validator nodes, we get to do things much more better than everybody else that is just running validator nodes, just, for the economics part of things. And then, we'll talk about, once we are done talking about the concept, we now talk about, there are two parts to setting up a validator node. There is a key generation process where we generate our key, our validator key, and then we upload our validator key. We upload our deposit data, and then we now set up the software, which is like all the software components that makes up a validator node. So yes, I feel like this is the usual thing. Like, yeah, my name is Dial, and I've been working in the Web2 infrastructure space for more than 8 years now. I've helped a lot of startups, which are now successful companies, build their blockchain infrastructure. So, startups like Flow Blockchain, Flow is not a startup anymore, Composable Finance, Obol DVT, and a whole lot of others, right? Yeah. So yeah, someone is asking whether it's testnet. Of course, it's testnet. We are not going to be risking or learning with $100,000. So yes, it's testnet. So yeah, currently for me, I'm an infrastructure builder. I build the infrastructure where all of us build our applications on, right? So for me, I am very much invested in making sure that we also have much more infrastructure builder in the ecosystem, right? So yes, about us, I've gone through this. I think I'm just going to skip that to save us like the whole product talk, right? So yeah, I talked about what we are going to be having for our product series, and yes. However, if you are here and you didn't watch, or you were not here last week, I'll recommend you go through our last session that talks about DVT. So if you need that link, someone will drop it in the chat for us, so we could, you could go back and have like a refresher course on it. All right, now remember, just to do my own recap, right? Last week we were talking about how to leverage distributed validator technology to achieve two goals. One, to create a form of like, a form of passive income for ourselves, right? And secondly, to also be or participate in Ethereum Validator or Ethereum security as a validator, right? So that means that, and one of the things that Ethereum is trying to do is to decentralize the way that people secure its network, right? I remember from our talk last week, there are different people that are currently participating in the security of Ethereum. There are the enterprise or the big exchanges like Binance, like Coinbase. There are the big staking as a service companies like Lido and Figment and so on. There are a lot of these components, but one of the problems currently that the Ethereum ecosystem is facing is that all of these people that are securing Ethereum, like Ethereum as a network, all of them seem to be in a cluster, right? And if there's anything that we know Ethereum for, Ethereum is very, very big and very, very serious about decentralizing everything around it, right? So it's not just enough that you have a decentralized network. Ethereum is very, very conscious around the fact that a decentralized network doesn't slowly become a centralized network, right? So, and one of the things that the Ethereum network really talks about is decentralizing the validator network by creating more opportunities for solo stakers to participate in the network. Now, the idea of solo stakers is that if you have more individual people or individuals rather running validator nodes, that means that the network is much more decentralized than having only Binance, for example, running thousands of validators, right? So, but instead, if you have thousands of individuals, we can, and the reason why that is important is because, for humans, right? Humans literally work, if you think about human nature, we literally work with incentives, right? Self-interest, right? So we just want to make sure that, or the Ethereum network just want to make sure that our self-interest is, or our interest is, lies with the good of the network, right? So that means that in as much as everybody is coming together to secure this network, we want to make sure that there is incentive for people to do this. At the same time, we also want to create disincentives for people not to want to act in, the other way around, right? Against the system. That is what the whole validator network is about. Now, we talk about the challenges that we faced bleeding or running a validator network. Like the challenges why it is very hard for individuals to run validator network, which is around two major things: slashing and penalties, right? Slashing is when a large portion of your staked it is burnt and, you're also kicked out of the system. So it's a lose-lose for you. And penalty is like, just like maybe like a little portion, or you missing reward, or you losing the reason why you're losing the reward or the value for the reason why you are being a validator on the network. So those are two major challenges, or two major, and then we now talk about the risk, which are like the risk of key theft, whether it's from humans or from like cyber attacks, or hiring wrong employees, right? So we talked about this, and then we now talked about the fact that a way for us to get rid of this problem and create a truly decentralized validator network is to use a technology called Distributed Validator Network. Validator technology. So basically what this does, based on our explanation last week, is that it distributes the risk and the responsibility of one single entity being a validator amongst a certain number of groups. And everybody can now behave collectively and, with consensus, of course, and still continue to perform the same functions, right? So yeah, so that's sort of like the whole basics of the old DVT that we talked about. Now, today we want to now see how to set up a validator node. So today we are not going to be talking about, we are not going to be thinking about DVT as a technology. Today we want to put ourselves in the shoe of a validator node runner. What does it mean to be a validator node runner? What are the things I need to do to be a validator node runner? And that's what we're going to be doing. So yes, all right, getting started. So yeah, just to quickly brief through, we already talked about who a validator is, right? Now, there are a couple of components in validating the network, right? The first one is slots and epoch, right? I want to explain what that means, right? But before I explain what that means, I want also to have some foundational illustration, right? So like, remember, let's assume that, I think for this illustration, let's assume that everybody on this call, I think currently we're about 12 on this call. Let's assume that all of us are building our own blockchain network, and let's call it Breeders Connect. Like, Breeders Connect network. We have our own coins, maybe BDC, whatever. We have our own coin, and we have people that are building on our network. And we also created a way where everybody, or we have like roles and responsibility where everybody here is responsible for agreeing on checking transactions or activities that happen in our network and looking at it and saying, is this a valid transaction? Yes, it's a valid transaction. Move it, approve it. No, it's not a valid transaction. Let's have that illustration, right? Now, and that is how, like, that is literally how the blockchain network works, right? We have the decentralized mechanism. We have individuals or nodes that are participating. Everybody have their roles and responsibility. And what everybody is basically doing is doing the same transaction we do in the Web2 world, but doing them using that old ledger or distribute in a decentralized way where everybody gets to be part of that system. Now, how do we make sure that people are doing this, right? Or how is this done, right? Now, doing this, we have, if you've read about Bitcoin and all of those things, you've read about like the ledger system. So basically, what happens is that for everything that happens, like let's say it's a transaction or it's a message or whatever happens, everything is being written down in a ledger, or let's say a sheet of paper. Everything is written down. Some people have the responsibility of validating this transaction that it makes sense, or whatever it is that is written that it makes sense. These people are called validators. Once this has been validated, what happens is that we now move this to the block and share this amongst everybody in the network and say, oh, this transaction happened. Now, when we share this, what this means is that everybody automatically have that record, the record of that transaction. And, it's unchangeable. And, moving forward, everybody have that record, and any future transaction that wants to happen, everybody else in this network can easily go and check, the state of that previous transaction. And it's going to be true for everybody in this network. Anyways, now moving forward to how this relates to validator network. So now, slot in validator for a block productions, right? Or in a blockchain network, there is block production. A lot of people see block productions. You see blocks, like Ethereum is on like how many million blocks now. All of us sees block, but we don't really think about what goes into each block production that happens, right? And one of the things I first of all want to show us is what an actual block production looks like, right? So 1 second, let me quickly share the screen. So this is one of our network. Pardon me, I'm using this Polkadot because it explains what I'm trying, or illustrate what I'm trying to explain. This is one of our network on Polkadot, and this is how you see block production. Now you see on Polkadot, they are currently on block height 20 million, 400 and and you can see that at every 6 seconds, a block is being added, right? Can you see? You can see that every 6 seconds, a block is being added. That is literally what happens in a block production in any network. Now, all of this is what I'm going to be explaining now in the concept of now for slots. Now, a slot in Ethereum is basically a chance for a block to be added in the Bitcoin chain, just like we just saw now in the illustration I showed, right? A slot is for every transaction that happens, or whatever it is that we write, we push it or we add it to a block, right? So that action itself, or all the transaction that we had in that period, is what we call a slot. So basically, a slot is a chance for a block to be added to the Bitcoin chain. But remember, we don't just add blocks. We need people to validate that these blocks are right. We need to make sure that everything checks before we add the block, right? Now, let's assume everything checks, right? Which we still go back to into explaining like what goes into us checking like a validating. Now let's assume everything checks. We now go on to talk about epoch. So epoch is basically the time period, right? Epoch or era. Some blockchain calls it era, right? Era is basically like the English term, basically like a state in time or a period in time. That's what epoch means. So when you now say slots and epoch, that means that the blocks you have that are meant to be produced at this point in time, right? To now illustrate this further with our polka dots, you now see that at epoch, at this epoch, for example, like for every 4 hours, right? How many blocks or how many transactions, are pushed to the blockchain network or are validated on the blockchain network? That is what epoch and slot means. And to also illustrate, a slot for a block to happen, for a block to be created, it takes about 12 seconds, right? That is on Ethereum. You can see that on Polkadot, it takes 6 seconds, right? There are different reasons why this happens. Like these are protocol devs, we understand this, right? There are different reasons why this happens. But for Ethereum, it takes about 12 seconds for a block to be added to the network. And for each epoch, there are 32 slots. So that means that it keeps adding the block, and once it reaches 32, it creates another block. Yeah, someone has a question.
No, you can go on. I think you retracted. Go on.
Okay, all right. So now, I want us to have that understanding at heart. A slot is basically a chance for a block to be added. An epoch is an era or a state in time of a blockchain, right? And if you also look at the diagrams, you can see slots. So you can see if I zoom in. So sorry, if I zoom in on this, you can see each slot. Look at all these numbers from 0 to 31. These are all slots. And inside each slot, this is where all the blockchain data for that particular time period, which is an epoch, this is where all those data lies. So whatever transaction that happens between in epoch, maybe 2 or whatever, right? You can find it in these slots, right? So this is basically what this means, right? And then the next thing I want to explain is the validators and attestations, right? Remember, I think we also talked about this, that for a validator have 2 responsibilities: validating or voting on the validity of a transaction, 1, and proposing or producing blocks, right? So the first thing that happens is that someone proposes, like remember, we are in a network now. Someone says, oh, okay, there's a new transaction that is about to happen. Someone proposed that transaction, right? And then what happens is all of us now have responsibility of validating this transaction, the correctness or incorrectness of the transaction. All of us validates it. And once we validate it, we now agree, which is the consensus. We now agree and decide, okay, we want to move this transaction, we want to add this transaction to the block. So the process of adding that transaction to the block, what we now do is in a slot, right? So all other transactions we are adding in a particular time period is now, the epoch, right? And then we now talk about the attestation. Now, a block proposer is a validator that has been pseudo-randomly selected to build a block, while validators are attesters that vote on the block, right? Which is basically like what I explained, right? The reason why I highlighted pseudo-randomly is because I want to explain what that means, right? How does the blockchain actually choose what blocks to validate or what blocks to push? I'll also explain that. So now, if you zoom in on this, I don't know if this zooms, but if you look at this diagram also, you will see back to the concept of what we explained. Those blue rectangles, those are our blocks, right? So these are our blocks in each slot. So you can see slot 1, slot 2 to 30 to 32. Remember, we said that in an epoch, there are 32 slots. An epoch can only take, 32 slots, right? And then all these dots you are seeing are just, blocks that validators have pushed to the network. However, you can see this space here, the missing space here is basically illustrating that a validator failed to perform his responsibility, which is that he probably missed a block production. He missed a block production. Now, the validator that failed to do that will be penalized, right? That's what this illustrates. Now, committees. One thing about the blockchain or the Web3 space is that whatever most namings have literal meanings, right? So if you think about it, committees, like you just said, we are all of us on this call, we have our own network. So we now create a group of people that their role and responsibility is just validating the network. So what we now do is we now create a committee of validator runners, of validators, right? So basically, a committee is a group of validators. Is literally basic English. However, this is why this is important, right? In a slot, remember that a slot is a block that has been put, that is being added to the network, right? What now happens is that before a block can be added, what the beacon chain does is that it pseudo-randomly selects random validators or random people and create a committee, of them. So it selects like 128 validator each for one committee, right? Let's say we now have like 10 committees. So it creates like 10 committees of validators. So that's like about, 1,280 validators, right? So it creates all these validators, create them in a committee. And basically what happens is that in each committees, everybody will now still perform the responsibility of a validator. Everybody look at a transaction, they check whether it's valid. If it's valid, they propose that this transaction be added to the block. Now, each committee does exactly the same thing. Now, what the big country now does is, in as much as it has created these committees of different validators, pseudo-randomly selected, what it now does is, most likely than not, everybody is going to come up with a block that needs to be added, right? With the same block that needs to be added. So what he needs to now do is, most often than not, everybody is going to agree and be right on the valid transaction that needs to be added to the block. But what the algorithm or what the consensus or the beacon chain wants to do now is, how do I do this? How do I do this in a decentralized way that is completely pseudo-random? That is part of the responsibility or the roles of the consensus client, which is what we call the beacon chain. Part of the work it does is, when all of these committees are set, currently, remember, we have like 1 million validators. When all of these committees are set, it's pseudo-randomly pick committees, and in each of these committees, everybody have the rules of trying to vote a transaction. There is someone that you also pseudo-randomly picks to propose a block that is going to be added. At the end of the day, it now selects one block, right? It selects one block based on the rundown, it selects one block, and then once it selects one block, the idea is that the committee have already agreed and they've decided which blocks that needs to be added. All he's just doing is, just closing his eyes and picking one and adding it to the block, to make sure that, it's not partial or whatever. But there is one other thing that we need to know, right, is that the way he also does that is that, it's almost like committees, like when we are trying to agree, it makes sure that it is majority carry the vote. So we call it super majority, right? In a blockchain network, in as much as it's decentralized, right, it is not all the time that everybody agrees on the validity of the transactions, right? There are some times that some people believe that this transaction is wrong, is right. Some people think otherwise. So part of the responsibility of the beacon chain, outside of just randomly selecting the valid block and pushing it, is also making sure that is choosing the majority, the super majority. So the super majority is now basically two-thirds of the committee, right? Remember, it forms the committee, then two-thirds of the committee is now the super majority. So it doesn't matter what the remaining one-third says. Like, since the super majority agrees on the validity of a transaction, it just randomly picks, and follows whatever the super majority says and propose that transaction. That is all about like committees and slots and epochs. Now, checkpoint, right? For each of these transactions or each of these blocks that is being added, remember so once I've added a block, I have another work, I need to add another block, right? Now, checkpoint is basically a state in time where we justify or we decide whether or not, where we can still make a change or where the consensus algorithm can still, is that to explain. But like checkpoint is basically a state in time where any reversal or whatever, or if someone wants to reverse or come back to a state in time, they can easily come back to and I'll still, when I talk about finality, this will make sense. So checkpoint is basically like the last accessible state, right, of a network, right? Then we now talk about finality. Finality or finality, as some people say, is basically the no return of a block or the point of no return for a block. So if a block reached finality, so you can imagine all of the process that we talked about. Meanwhile, all of these things I talked about happens in seconds, seconds. Now, once all these processes have happened and then a block is being produced, right? The moment a block is produced and is final, that means that nothing can change it again. That is what the whole point of finality means. That means that once the supermajority have agreed, right, on a vote, right, once they have agreed on a vote, nothing is going to change it, right? And, remember, for a validator node, you either vote on a transaction or you vote on, or you produce a block, right? Those are your responsibility. Now, in voting a block as part of your responsibility of voting validity of blocks or voting as a validator node, there are two types of votes you make, right? There is the vote you make to attest to the validity of a block, right, is called LMD ghost vote, right? While the vote you make to ascertain a checkpoint, like a state in time of a block, is called this Casper FFG. We don't need to worry about that. Those are protocol terms, right? But the ones that we need to worry about are slot and epoch, attestations, because attestation is the number of time you vote. And if there's anything that you are going to be doing a lot as a validator node runner, is that you are going to be voting a lot. So your attestations matters, right? And then finality, right? These are things that really, really matters when you are running a validator node. Any questions first before I move on? Any question? Are we good? All right, Miracle.
Hello, good afternoon. Can you hear me?
Yes.
Okay. I want you to kindly go over the committee explanation again. I kind of like don't really understand what you mean by having like 120 you know in one place. I'm trying to understand it more.
All right. So committee is basically, I mean, think about it, right? In maybe in whatever group you belong to, at one point or the other, you people have formed committees. Maybe it's committee that is responsible for um, maybe finance committee that is responsible for like managing the finances of your group, right? You realize that that committee, in as much as everybody belongs to a group, that committee can come to can come and say, oh, we've thought about it. We've decided that is 1 million that we need in this group to survive, or whatever, right? So think about that concept, and in the concept of validator nodes, of running validator nodes, what the beacon chain does before, or how the beacon chain is able to decide or add a block to the network, is that it looks at an epoch. It looks at the slots in an epoch, right? So remember, what contains a slot are like the validator addresses and all the transactions and everything. That's what's in the slot, right? The blocks, right? So it looks at this time period. It looks at all this data in this time period, right? And then it brings validator together, and then it says, okay, you know what? I'm going to divide you guys into committees. In each committee, there's going to be 128 of you, right? 128 of you in each committees. And I want all of you to look at all of these transactions in this epoch, right? Look at all these transactions. Tell me which one is valid. Tell me which one is valid so I can add it to the network. Do you understand? That is, so you see, so what it now does is in that, so once everybody in that group, but you can, if you think about it, right, because you are forming groups of so many people, what happens if you have some people saying yes, this transaction is valid, and you have other people saying no, this transaction is not valid? You need a way to be able to mathematically, or to justify whatever decision you make, or you need a way to make sure that at every point in time, whoever you go with is right. So what it does is that it uses the supermajority vote, which we also do in committees, where everybody in the committee can vote against an idea or vote for an idea and say, oh, aye or nay, right? So that process of you voting aye or nay, what the consensus just needs to know is that how many people voted aye, right? You just need to know that 2/3, which is like 66% of the entire committee, voted aye for a block. As long as that happens, the consensus algorithm is going to, or the consensus is going to add that block to his network. That is basically what committee does. Does that explain it?
Yes, yes, it was. Thank you very much.
All right. All right. So now, moving on. So we've basically talked about all the major concepts that we know to talk about. Yeah. So yes, I don't want to go into some protocol stuff. These are for protocol people. But the other thing that we need to know is that now for you to run a validator node, the important things or the important metrics that is important for you is these are the, I mean, I just listed them, but I want to say something that the reason why I explain all of these things is so that when you are trying to optimize for the performance of your validator, it's easier for you when you understand what a slot is. Because part of the things or your performance metrics, just like we have at work, part of your performance metrics are things like your attestation, right? Your attestation rate, which is how much vote or how many times you vote for a transaction in an epoch, or your block production rate, right? Which is how many times you're able to propose or produce blocks, right? These factors are here. These are the things that makes up your performance metrics. And at the end of the day, what is your performance metrics? everything boils down to how much money you're able to make as a validator, right? So if you now think about it, if you're able to get everything right here, that means that you're able to, be an effective validator where you are not slash, you are not losing your reward, and you get the optimum best out of being a validator in the network, because you understand everything, you understand everything, and then you are looking out to make sure that all of these things that the consensus, because most of them are not, people don't understand how the consensus share reward or distribute reward. But when you understand all of this, you now realize that once I'm able to effectively vote for or validate a transaction, which is attestation, I'm able to vote for a checkpoint, I'm able to produce block, or there's another one that proposed block, there's another proposal, another validator that proposed block, right? I'm able to do all of that. And that means that, live a soft life. But when there's a dissonance between this, you just think that because you're running validator node and then you should just be getting reward. That is where people miss it, right? So that's the reason why I'm showing this. But yeah, that's like all the basic concept I wanted to explain, so that when we start running our node, we have very few minutes. Don't worry, I've already simplified a lot of these things on how to run our node, so it won't take so much time. But yeah, it is very important that you run this, because at the end of the day, as a validator node runner, once you set up your validator node and it's up and running, you are not doing so much. There is nothing else you are really doing other than maintaining the node. But it's easier for you to maintain something you understand, right? You're able to see how to make it much more effective. So that's the whole point of this. So now we are going to be going to two parts of I'll come back to this. This part is the node component, but I think that I should probably explain all these node components first. I'm finding out to zoom. Okay, you can see. Can everybody see that? So for your validator node, remember, for you to, after all of the things I've said, you need 32E to be a validator node, and you need to run 3 softwares: a validator node, an execution client, and a consensus client, right? Now, your validator node itself, these are the components. These are all the components. These are all the things that makes up a validator node, right? And I don't think, for everything we've talked about them, the only one that I will sort of like demo for us is the key generation, right? Is the key generation and the key generation and how we can run our node from anywhere. I'll also like give advices on best practices for setting up a node. So for I'm finding out to see this. Sorry. 1 second. All right. So for the key generation, you can see the node components. I don't know if you guys can see, but there is a launch pad. I'll show us the launch pad. The launch pad is where you generate your validator keys, right? So you first of all generate your validator keys. You have your withdrawal address. Your withdrawal address is where your reward is going to be going to. And remember we said that you are going to need to stake 32 ETH, right? So there must be a way for you to stake that 32 ETH. So you need to now send your 32 ETH deposit. There is a way for you to do that through the launchpad. That is what this part is saying. Now, then the validator client that I just explained, we don't need to worry about how that works for now. I mean, we already talked how that works, but we don't need to worry about like the software component for now. Then the consensus client, the execution client, and then there's Mev Boost. Now we'll explain what Mev does. But I think that all the other components, we already have an idea of everything, the Linux server, the keys. We already have an idea of all of this. The only one that we don't have an idea of is the Mev Boost, and I will explain that. And it also ties to how to be a better validator, right? So now for Mev Boost, but there was something else. Yes, yeah, so I wanted to talk about different clients, right? So in Ethereum also, remember we just talked about execution client, validation client, and consensus client. Like I said, Ethereum is very, very big on decentralization on every component. Now, you will find out when you start running, you will see when you start running your clients that they are different clients. They are different people have different clients, or different companies come together to breed different clients, right? Like so let me quickly share that for us. I think we have it also in the slide. 1 second. So yeah, you will see Nethermind, Besu, Aragon, all of these are doing the same thing. They are all performing the same function, but built differently. So some are built with different languages like Go. Some have things that they prioritize. But the reason why is because, again, decentralization. You want to avoid a situation where everybody is using the same kind of software and something happens and maybe someone injects a malicious code to that client and the entire network, is collapsed. But now when we have less than, 66% running each client, it creates more decentralization where everybody knows that even if Nethermind goes down, there is prison or there is Git, right? That's your point of the clients, right? That's what that whole client is talking about. But for the MEV boost, right? MEV is basically maximum extractable value. And I think I sort of just talked about it, but I didn't talk about the terminology in the sense of how do you get the maximum reward from being a validator, right? I already talked about once you understand all the basic concepts, things are easy for you, right? I already talked about that. Once you understand it, you know how to optimize your validator node. The second part is there are also softwares that have been built to ensure that you get the maximum possible reward for being a validator. And that's what we call MEV. We call it MEV boost. Some people build this, but I'll explain it in simple terms. There are different transactions happen. I believe for all of us that have tried to send money on Ethereum or do whatever, there are different amount of money that goes, that cycles the Ethereum network. And think about it. If 3 of us are sending in a group and we decide to send 10 ETH, or which is basically about $30,000, right? And some validators are responsible for validating that. Think about that one. And then there's another set of people that they send 3 million ETH, right? You can imagine that there is much more reward for any validator that is responsible for validating that, each transaction, right? So what the MEV boost does is that it finds the possible best block that is going to give you the best reward. It finds all, because there are different blocks, there are different transactions going on in the Ethereum network, right? So what the MEV boost does is it looks for the best transactions, the, yummy transactions on the network. It gathers them and pack them into your block, right? And if you are lucky enough, if you're able to validate and propose that block, you realize that you not even get more reward than the actual reward that everybody gets. To put this in context, right? The highest number of, or the highest amount that has been extracted with MEV boost with software. Yes, exactly. So it looks for transaction, it looks for the best. So you just gather all these transactions and just try to make sure that you are in the best position. And to put this in context, the maximum reward that one person has gotten for being a validator was about maybe 700 ETH, right? Imagine you just sitting, your node is doing the work, the same work that for every validation, for every epoch, when you get your reward, maybe you already get your 0.2 ETH, JJ, or 0.9 ETH. That's what everybody's getting and everybody's happy. But you now have one software that finds the possible, best possible reward for you. And in just one slot or in just one transaction, you got 700 ETH. It's just billing and balling for life. So a lot of people now have MEV boost to boost the reward they get, right? So that's what MEV does, right? So that's basically what MEV does. So a lot of people don't run it, some people run it, but MEV is sort of is a lottery if you think about it, because you might be lucky, you might be lucky, or you might not be lucky, right? You might be lucky, like the guy that got 700 ETH was just lucky, right? You might be, so it's sort of so the reason why it's mostly optional like it's not an essential part of a validator node, is because you might be running your node and it's getting the best possible transaction, but it still don't mean anything. But maybe something just happened. You know that some people used to make that mistake where they pay a lot more for gas fees, you know, on Ethereum network. There are some people that get, the people that get those money are the validators, right? And people that run Mev Boost have a much higher chance of getting those money. Do you understand? So yeah, that's it. All right, we don't have time again. Moving on to our demo, where I'll be talking about, or where I'll be showing how to generate our keys. So for you to generate your key, you will go to Launchpad. Let me drop the link for us. Yeah, so this is how to generate your keys. Remember from our previous session, we said that your validator key is basically what makes you a validator, right? Your validator key with the 32 is what makes you a validator. Now, in the launchpad, there are different launchpad. Because you're on testnet, you can see that it's already telling you that this is a staking launchpad for testnet. If you want to go to mainnet, all you just have to do is you can switch network, right? You can switch to mainnet here, or you can just change the URL. But for now, we are using testnet. So let's get started. It's pretty basic, right? You can follow the instruction and get it. Like, I don't even need to talk anymore. I can just send this link to you, send the link to some instructions to the setup validator node, and you'll be good. Because now you understand the basic fundamentals that a lot of people don't understand. But anyways, let's go ahead. So become a validator is basically a launch pad. Think about it like a instruction process. So it just shows me all of these things we've talked about, them, proof of stake, is asking me that, hope I know that I need 32 ETH to be able to stake. Yeah, someone said that even 32 ETH on testnet is expensive. It is very true. Before you will get 32 ETH on testnet, I had to do some proof of work. The 32 ETH I used to generate the key for this demo, I had to set up like a proof of work miner that was mining 32 ETH for me. I mean, for a long time before I got 32 ETH. So even that 32 ETH, see, I sent this to a couple of people for test, right? I had to beg them, please send my money back. You would think it's actual money, right? But like even that 32 it's expensive to, it's hard to get because all of this platform, the highest they will give you is 1 ETH, right? So, and they would rate limit and all of those things. So you need 32 ETH. I already have my 32 ETH. I think I should also let us know that I've already done this process. So we might not be able to finish it because once it sees that I don't have 32 ETH, I'm not going to be able to proceed, but I'll show us everything regardless. So it's just letting me know like all the basic things I need to know. It's also telling me that, hope I know that my validator needs to be up and running every time. That means I must have some technical knowledge of how to keep a node running, right? And then you're also telling me about the repercussions for bad behavior. That is, if I misbehave or if we've already talked about all of these things. Key management, which is the most important thing, right? It's also like letting me know, hello. So it's also letting me know that this is one of our youngest validators. Let's give it up for her. So yeah, it's also letting me know that I will need to generate keys and I will need to keep these keys intact because, like everybody knows, once not your key, not your money, right? Once your key is out, once someone else gets control of your key, that's it, right? You don't own the money that's on it. So these are all just basic stuff. And then there is now validator checklist. So what I'll just show us is the validator checklist. I'll go there now, and then I accept, and then it continue. So remember the part of the clients that I talked about. I already explained the reason why we have different clients. So in case you're wondering why so many clients, the reason is just for decentralization. All of them work. But I have my preference. I personally choose Go clients, mainly because I'm a good developer. It's also helping me learn when I go back to their source code and see how some things are done. But also because Go is very memory efficient, right? So it reduces less maintenance work for me as a validator runner, right? So I always go for Go clients, right? So you can choose between Aragon or Git, right? But let's say I choose Git, right? Then it will show me like the instruction to run Git, but don't worry about this. I'm just showing us the launch bar. And then it now shows me for the consensus client. Remember consensus, execution and validator. And then I choose my consensus client. I want to choose Prism or Lighthouse. I also always choose Lighthouse because Rust is also a very good, it's also very memory efficient. So between Go and Rust, these are the clients I usually choose, right? So, but for this sake, so it's not like we are only choosing Go, right? So I choose Lighthouse, and I continue. Then this is where I now specify the number of validators I want to run. Remember, for one validator, you need 32 hits. So if I need 64 hits, and in that order, then I specify my withdrawal address. So what I now need to do is, by now you should have MetaMask running, right? I think we should requirement. You should have like MetaMask running, or any wallet system really, MetaMask or Coinbase wallet or any other wallet that you trust. To be fair, you don't trust wallets, honestly. That's another conversation. But yeah, you now get like your withdrawal address, right? So now I have MetaMask. I created MetaMask for the purpose of this, and this is my withdrawal address. This is not my money, or this is testnet money. This is what is left after I've done deposit. So this is not my money, because. But anyways, I just pick one address that I want to use as my withdrawal address. This address is very important that I have control over it, because this is where my reward is going to be coming to. So you don't want a situation where you put any random address as your withdrawal address and it's time for you to cash out, and it's saying what is cash out, right? So yeah, and then it now asks you for your operating system, whether it's a Linux or a Mac, but most likely I'm using a Linux. Now, this is the part where I'm going to be showing us how to generate your keys. There are two different ways. You could, if you are like a programmer or someone that is very technical, you could use like a CLI. So you will need to go and download from this link. You will download the deposits or the key generation tool. So there's a key generation tool that you need. I just dropped the link. You would download it. Or on another hand, you could also, there's a GUI tool that works whether on your Windows or on your Mac. I downloaded one for the purpose of this. Let me show us. So it's called Wagyu. So Wagyu was built by the Stakewise guys. So this will just show us like the key generation process. Is a very simple process. Let me just share. Let me see if I can share. 1 second, let me share. Can you see my screen? All right, awesome. So basically, this is basically a tool. It's just a GUI tool that helps me generate my validator key, right? So one of the first things it will advise you to do is to shut off your internet to ensure that nobody is listening, is listening in on your key generation process, or is, when you are holding 32 hits, a lot of things is at stake, right? But for this case, we don't want to worry about. And since we are using testnet and we are using host key, what I'll just do is select the testnet I'm using and okay, right? Now I'm going to start my key generation process. So I'm pretty sure that for every one of us that have created like a MetaMask wallet at any point or the other, we probably have done this when we are creating a wallet. It's pretty much the same process as you creating a wallet, right? So create new key is a very simple UI process. So yeah, it asked me to create my secret recovery key. I mean, my mnemonic, right? So this probably take about 30 seconds. And once it's done, it's just going to come up with like, a seed phrase. So you need to keep, this seed phrase is basically your key, right? So you need to keep it safe and secure, right? Don't keep it anywhere random. That, just think about the worst case scenario. If someone have access to this, can someone get access to it here, right? These are kind of things I need to think about. So, but of course, maybe as time goes on, we can also share more about how we secure our validator keys, right? So you see, it generated like a mnemonic for you. you copy it, and you save it somewhere safe, right? So let's assume I've saved mine. I've saved mine somewhere safe. I've locked it. Then I move to next. It's also making sure that I ensure that then it's confirming. It asks me to like copy and paste or like rewrite those mnemonics to be sure that I have them. Then it checks. Then it asks me how many keys do I want, because I'm running one validator. Then it asks me to add the password to use to decrypt that key, right? I add the password. Then the withdrawal address, remember, very important. So what I do is I come here to my MetaMask wallet, copy my withdrawal address, paste it, right? And then next. Then he asks me to retype the password that I'm going to use to decrypt the key. And then I type it. Then he now asks me, where do I want to save this key? So I can now come here to anywhere and say, okay, I want you to save those keys here. Because what is going to happen is that it's going to generate my deposit data, right? And then save them somewhere. So let's say I want mine to be saved here, and then I click create. So what it's going to do is going to generate my deposit data. Remember I said that what this process is doing, what we are doing in this process is we want to upload our deposit, our key, our validator key, and we want to generate our validator key and our deposit data. Our deposit data is basically the data that contains our wallet address, right, including the private key and then the 32 ETH stake that we are putting, right? So I do this. Once I do this, if I come, you see that it has already generated it, right? And then I can close, and that is the end of the key generation process, right? So once I'm done, right, you can see all of this process that I was talking about is just what goes on here. Then it will ask me to upload it. So upload my deposit data, because there is a particular address that deposit data goes to. Do you understand? So what I now want to do is upload deposit data, and so this is one I generated already before this call to save time, right? So I'll just upload my, don't worry, it's just for test purposes. So because this is already exposing sensitive information, but because it's just for test purposes, so you see, if your deposit data is not correct, it's going to reject it, right? So it validates that you have your deposit data, continue. Then the next thing you now find is that, oh, you don't have 32 ETH, right? So that means that you can't proceed. But because, like I said, I already generated mine, so I don't need to worry about all of this remaining process. Now, the next part, so now I already have my deposit data, I already have my key validator keys. So let us go on to set up our validator node. So the most easiest resource for you to use is not the most easiest. This is one level of difficulty, right? Because you still need to do all of these things manually, right? So I just shared the resource with you. Is what I'm going to be using. Is what I'm going to be using to set up our node, our validator node. It's quite easy if you have experience working with terminals and Linux. It's quite easy. Or if you understand Docker Compose, it's quite easy on some technical level. But I will show us that. But then once I'm done, I'm not even going to show us a very much more simpler way of doing it, right? Now, I need to share my terminal, but I want to share three things together. Let me see if I can do that. Let me bring my terminal. I lost my browser. 1 second. So I want to bring my terminal so that when I'm running the command, you will see. But that instruction that I just shared us, this is where all the major instruction is, like everything we need to know, every instruction we need to set up the validation client or the execution client, the consensus client software, everything we need to know is there, right? So yeah, I'm bringing my terminal so we can see as I'm doing it. So the first step is so all of those things can be found in this repo. This process that I just simply shared with us here like this. There are some people, they call them like the Ethereum educators. They also do the work of simplifying that process further. Because otherwise, you have to manually install a lot of components, manually do a lot of things. But there's a bootstrappable or easy way for us to do this using this guide. That's what I just showed us, right? It's quite easy. Like, you don't need to even stress, and you will see it too. So this command is basically me just downloading and just cloning the repo and seeding into it, right? Oh, sorry, I want to do that. I created a machine for this. I want to do that from a Linux machine. I don't like stressing my laptop. So yes, so I already created a validator demo machine. So what I want to do is, where is the instruction? Clone the repo. Like I said, we are just running the validator node because I want us to see the validator node hub, right? We clone, and then if you just run this, what this does is that all of the components that you're supposed to manually install, this is going to automatically install them for you. And then if you say yes, right, it's going to do all of the gimmicks. If you care about seeing what's happening, you can go into the code that I just shared and see what's happening, right? Once you do install, the install basically just install the basic components, right? And then once you are done, then the next thing you do is the config, right? So the config is also like other components, other configurations that you need to have ready before you now run your validator node. So it's basically asking me what network do I want to run on, whether it's OSCI or Ethereum mainnet, or I choose, since you are using OSCI, I choose that. There is now asking me what kind of node do I want to run. Is it consensus, validator, execution and validator client? Yes, of course. But if I want, like, maybe what I want is just a full node for developers, I can also use this to set up my full node. Or maybe what I want is just a full node that connects to a staking as a service, or SSV, which is a DVT node. This is for our last series. But what we want for now is remember, the component of a validator node. We've done the part of deposit data. We've already generated our deposit data. We've already sent our deposit data details to it. Now we need to set up this software, and this tool is going to help us do that. So I select that, right? They now ask me the client, just like the Launchpad was asking me. You now ask me for the client. Remember, I said for consensus clients, I like Rust, or I want to choose Rust for this purpose. For execution clients, I want to use Git, personal, but Aragon, right? And then see now for the checkpoint. So you see what I was explaining around you understanding some basic concept. So remember, for the checkpoint, me saying that the state, a particular state in time of a network or of a block, right? So what this means is that what this is doing for us as a validator is that for you to run a validator node, you need to sync your execution client and your consensus client. And the last time I checked, I can't remember the last block that the consensus client is on. They are very, very far, like maybe like more than 10 million blocks. So syncing process means that you will need to download the entire state of Ethereum network from the beginning and download it. Sometimes that is why you see the requirement for validator node is like, a large hard disk, a very fast, computer as well. But sometimes you really don't need to wait that long, or you don't need to even download all the histories of the blockchain. But you can start from a particular checkpoint, right? Like a very easy checkpoint or a closer checkpoint, right? That is a state. Maybe like you want to start from like checkpoints, maybe you want to start from like the first 10 million blocks. Instead of starting from like block 0, you want to start from like block 10 million, right? That's what checkpoint is doing. So there are some services that have already like checkpoints some of this for you. There are different configurations. You can configure this further, but for now, we won't be doing that. So you can configure this further. Maybe you are bleeding something that you require the state or the histories of your blockchain. But for now, we don't really care. So that means that if I choose this, instead of my node to spend a lot of time syncing from scratch, it's just going to sync from maybe 10,000 blocks or 1,000 blocks behind. And in a few minutes, my block is synced, and then I can get started easily. The next thing it's going to ask me is, do I want MEV boost? Of course, I want MEV boost. I want to increase my chances of, making better money here, right? And then you're now asking me what are the relays for my mail boost I want to use. I select that. There is now asking me for Grafana dashboard, right? So this is basically our visualization. How do you want to like see or get observability into what is happening into the performance of your node or like the operations of your node, right? So, and then again, it's not asking you for your withdrawal address. Remember, I copy my withdrawal address, paste it here, right? And okay. So this one is not saying, do you want your blockchain or your validator node to have like a unique name? Because remember, everybody can see themselves on the Explorer, right? So that it's easy for you to identify yourself instead of using your public key to want to like validate it, right? I saw a question now that says, if everyone uses Mail Boost, is it still a boost? Yeah. So which is why I said that it's a gamble, right? Because now if everyone uses it, the probability of you getting it gets slimmer, right? But at the end of the day, you still have a chance. Do you understand? Compared to someone else that doesn't. Do you understand? It just gives you a higher chance because what Melville does is it just makes sure that it collate and arrange blocks in the right way, the ones that is going to get you the best reward possible. So imagine you not having that. You are just going to be, free and wild, right? You are just running validator nodes for vibes because sometimes, validator nodes also depends on yeah, exactly. It's basically a lock thing if you think about it. It's basically lock, right? And the thing about lock, mathematical lock is that, at some point you actually be lucky because the statistical or the probability of you being is still going to happen. I mean, if you stay long enough on the network, you actually get lucky. The only problem is that I think the way to think about it is not to think about it in terms of like huge payout, but think about it in terms of like optimized payout. So that means that for sure that if you are using the MEV boost, that if you are using the MEV boost, that you still have better chance because your validator node is working in an efficient manner. That means that it's validating all the right possible blocks, right? And so, I mean, if you are doing something well enough in the right space, you just, I don't want to go, but you get lucky, right? That's what happens. But if you are doing something but in the wrong space, no matter how much, even if law comes, it will meet you there, right? So that's basically what Mevbu does. So for the graffiti, it's just like a pseudonym or whatever name you want to have. So we want to call our own Bleeders Connect or something. Then, so what this does now is, you can see that all of those processes is set up my Mevbu, set up my validator keys, set up everything for me. And I can just sit down and just wait for it. So when this is done, one last step we are going to do is run it up, right? And then what this is going to do is now, so this is just preparing all of the components I need for the execution client, is downloading the binary, the latest binaries, or the latest Docker image, is downloading the latest version, preparing all the configurations, setting environment variables, it's doing all of that. And then once it's done, I can now spin up my validator node. But it's going to be done in a bit now because we are also out of time. It's going to be done. And once it's done, all I just now need to do is to import my key, right? But there's something I'll tell us before we import our keys, right? Which is very important. So all the things that we've learned, right? Let me just say it while we wait for this. So because once I'm done now, I think I've shared the link with us, right? But there's a link to see the key that we generated earlier. You will now need to now import it into your validator node that is running. But remember that you get penalized if you are online as a validator, because the moment you import your validator keys, the blockchain network sees you online as a validator. But if you don't wait for, which is what I want to talk about. If you don't wait for your validator node process to finish, if you don't wait for your execution client to be fully synced and your consensus client to be fully synced, and you rush to import your keys, and the network sees you online, what the network is going to see is that you are online, but you won't be able to produce or validate blocks because your software is still preparing, is still syncing, and then you've not even started, you're already getting penalized. You can see why. So that's the reason why. Sorry. So if I run this now, it's going to spin up a node, and we'll see our node up and running. And you'll see the execution client syncing, you'll see the consensus client syncing. But remember, like I said, you need to wait for everything to be fully synced and everything to be checked before you now do the last step of the equation, which is importing your keys. That's once you import your keys, bam, like this, it activates you as a validator, right? Exactly. So if your node is not synced and you went to rush to import your keys, the moment you not even launch, you're already losing money. Do you understand? So now this guy is done. For people that are familiar with Docker, if I run Docker PS, you will see that you can see. Let me try and expand this a little more. So you can see that all of the components of my validator node running. One of the things we've already set is that you should open is that we've already set up Grafana for visualization, because I can imagine you just seeing all this terminal. It doesn't make sense to you, right? So what we want to do is let us see our validator node in action. Let me say open on port 3000. I'm doing this because I already know the port that Grafana runs on, right? So if I do this, sorry, let me just come to my browser and come here. So this is going to provide visualization into my validator node. And I can come here, come to dashboards, and I can now say, like, my home staking dashboard. You can see that my node is running. It's showing me my requirement, my node requirement, all the node metrics. Like, okay, my node is up. My consensus is synced. You can see the reason why our consensus was quickly synced is because we started from a checkpoint. Otherwise, it will have started syncing from 0, right? The execution node the execution client 2 is syncing. You can see all of this. So until the execution client is done syncing, that is when you import your keys. And that is the moment you import your keys, which is running the command I just shared. Once you run that command, you become activated as a validator node, and you are a validator node live. I mean, become a validator live, right? So all of these are just dashboards that, as time goes on, you start understanding more about these dashboards and what they do and what they mean, right? Another thing is that there's another dashboard. Let me see if they have it yet. So if you want to see the logs for your node, so this is where you see all the things that is happening, right? So there is, as time goes on, right? So there's now a place for you to now check your validator and the reward, right? This is, one second, let me. Bitcoin chain, yeah. So this is where, if you need to, so you can just copy your validator key, public key, you will see your validator live and see how it's performing. Let me just show us random validators. Right. So on mainnet, for example, I can now see all the validators, right? And you can see all the actions. You can see, oh, this validator voted 30 minutes ago. You will see yourself here too, once you are validated. Once you're active. This validator voted 30 minutes ago. These are the most recent epochs. These are the most recent blocks. If you now want to even see more details, like maybe you want to see validator leaderboard. Who are the people getting the most reward, right? You also see all of these details. You see what I said, right? So this validator stake 32 ETH, just on validator, the income in the past 31 days is literally just 0.3 ETH, right? Meanwhile, as time goes on, you'll be seeing some people that, you'll be seeing much more higher stakes and you'll be seeing much higher rewards. So the reason why you can, if you ask yourself, the reason why this guy is taking 32 ETH, everybody's taking 32 ETH, but one person is getting rewarded 0.3 and one person is getting rewarded 1.2 it boils down to all the things that I said. Maybe one person missed a chance to propose block, or he missed his duty at one point or the other, and therefore he didn't get rewarded. Or maybe this person is using MEV Boost, which guarantees that he's getting more valid transactions and more, good transactions, right? So so you can now view like the metrics and the state of your validator on this endpoint, on this Explorer as well. So that's basically all that it takes to set up a validator node. But remember, as a validator, the most important thing to you is your validator keys. All right, keep your validator keys intact, keep it secure, and you'll be enjoying life. So you can now repeat the process. Maybe you have another 32 ETH, you can repeat the process and continue going like that, right? So that's basically everything. Now, I said I was quickly going to show us another faster way, and that is involved with block ops, which is basically a simple way for you to set up your node. You see all this process I just did on the terminal, you don't necessarily need to do all of them, right? So you can easily come here. We have a tool called Mission Control, where you can now set up like an Ethereum node, or depending on the network you're working for, right? So let's say I want to set up an Ethereum node, for example. I can now select testnet. I want to do OSKey. Then next, whether I want an execution client. Let me zoom this. Can you see my screen? Yeah. Whether I want an execution client or a consensus client, and then next. So I put my details. Currently, it's just Git that we support, right? And then I select the version, select the consensus client I want, and select my project name, Bleeders Connect, right? And then I can also select all the other configurations that in the terminal you have to like do and CD and manually configure. You don't have to do all of that. You can do all of those things here, but we don't need that for now. I come to next, and then next, and then I now set up. So one of the good things that we're also working on that we're going to be releasing soon is you can now decide to deploy this anywhere, whether it's on AWS or GCP or dedicated VPS, maybe like a physical server that you have in your house or that you rented somewhere. So you can now do all of this and deploy them somewhere, right? But for now, the one that you can use for test is like a GCP. Let's say you want to deploy to GCP, you upload like your service account key, right? Once you upload your service account keys, it does those verifications, does all of those and all of the configurations that you need to set up like a VM basically. So you don't have to worry about that. You select the node type. I want a full node, and then it now does like a estimate for you of how much it's going to cost you. Because at the end of the day, you also don't want to be running a VM that when you do your maths, the reward you are getting from being a validator and the amount you are paying for your node infrastructure is not balanced, right? So it gets you the estimate next, and then you configure all of the basic stuff, and then you click deploy, and then you have your node deploy like this, which is the way I used to set up the node I showed us that I just used. This is the way I used to set it up, right? That is block ops. Then finally, before we go, I just want to also show us that, remember, I've showed us different ways to set up like validator nodes. You could use cloud providers like GCP, AWS, DigitalOcean. But the problem is that you are at the risk of censorship, or sometimes, like I said before last week, AWS and GCP, they are very expensive because you pay for bandwidth. It's not advisable, right? Except maybe you have credit, right? So it's mostly preferable you go for like a Linode or Etna or DigitalOcean, or have your own rack, right? Now, of course, you don't need to have your own rack also. There are now some people, they call them dark node or Avado. So dark node now creates like a basic home computer setup. This home computer setup already have an Ethereum Validator node, all of the components that you need. You already have them, the compute, everything. So it's just going to be like an hard disk that you just plug to your internet at home, and you are sitting at home. Once you configure it, you are sitting at home, you are validating. Once you activate your validator node on that box, right, you sit at home, and then as long as you can guarantee power for that your node and internet, you are fine. Do you understand? That is basically all that does. And that's like the last thing I wanted to share with us. So like, this is really awesome, right? I've shown us different ways. So, if you don't want to go through setting it up by yourself, like setting up a VM or setting up a cloud server, you could use block ops, right? Or if you don't even want to use any of those things where you don't want to worry about anything, you could also buy a hardware device or hardware box. So this hardware box basically comes with like a compute, a storage, everything that is needed for a computer, right? It just comes with it. And then all you just have to do is plug it to your laptop, do a couple of configurations. They already come with setup instructions, just like we did. Just do a couple of setup instructions, add your validator deposit data, and bam, you activate it as a validator node. So yes. That is it. That is it. I'm so sorry. I'm terrible with time. I'm so sorry that it took this long. I'm so sorry. But yeah, thank you everyone.